Equally important as describing the center of a distribution or data set is describing how spread out the data is. In this lesson, we will describe one very popular and important way to do this. First, let's consider the most basic way to describe the spread of the data. Simply subtract the minimum from the maximum. So, for our pulse rate data, the range is 91 minus 52, or 39 beats per minute. You have to admit it's easy. The problem is it's not very reliable. If there's an outlier, the result would be much different. Suppose there was a student present who had a pulse rate of 110. Then the range would not be 39, but 58. So we need a more realistic, reliable statistic to measure the spread of the data. A common mistake is to quote the range as an interval. People say the range is 52 to 91. In statistics, the range is a single number. It is the difference between the maximum and the minimum. So, on the way to defining this better statistic to measure the spread of the data, we take a step back and think about how to provide a little bit better description of the data than simply quoting the median. The median cuts the data in half. 50% is on either side of the median. Well, let's go a step further. We'll cut the data in half again. We'll call the median of the lower half of the data the first quartile and give it the symbol Q1. And we'll call the median or middle of the upper half of the data the third quartile and give it the symbol Q3. So what we have now are three numbers: Q1, the median, which is sometimes referred to as Q2, and Q3, that split the data into 4 equal parts. That is why they are called the quartiles. We define the interquartile range as the difference between Q3 and Q1. Since Q1 and Q3 mark off the middle 50% of the data, what the interquartile range does is it measures the spread of the middle 50% of the data. So, in so doing, it avoids all outliers and is hence a more reliable measure of spread. So let's go back to our now familiar pulse rate data. Previously, we found the median to be 72. Now, when the median is part of the data set, not the average of the two middle values, we do not include the median in either the lower or upper half of the data. We will essentially disregard it when calculating the quartiles. This is important. So each half has 11 data values. The lower half of the data extends from 52 to 72, and the upper half extends from 91 to 75. If we apply the rule to finding where the median occurs, it occurs for each half of the data at the 12th data value. So specifically, the lower half of the data has 11 observations. So the middle observation of the lower half of the data will occur at the 12/2 or 6th observation. 1, 2, 3, 4, 5, 6. The middle of the lower half of the data, or Q1, is 68. The same reasoning applies to the upper half of the data. The middle of the upper half of the data will occur at the 6th location. 1, 2, 3, 4, 5, 6. the middle of the upper half of the data is 80, and that is our third quartile value. So the interquartile range is the difference between 80 and 68, or 12 beats per minute. This is the spread of the middle 50% of the data. This slide summarizes the calculations of the previous slide and interprets our calculations. To say that Q1 is 68 means that 25% of the students have a pulse rate of less than 68 beats per minute. Conversely, to say that Q3 is 80 means that 25% of the students have a pulse rate that is greater than 80 beats per minute. So the majority of the students, the middle 50%, have a pulse rate somewhere between 68 and 80 beats per minute. And the IQR measures the spread of the middle 50%, which is 12 beats per minute. Before we leave the concept of the IQR, we consider how it is affected by outliers. So I have changed the previously low data value of 51 to 40. A pulse rate of 40 is much lower than all of the other data values. It is an outlier on the low side. Notice, however, that Q1 is still 68. The value of Q1 only depends on the middle value, not the extreme values. So it is important to realize that the interquartile range is resistant to outliers, so that when you have a data set that is skewed because there are either high or low outliers, the interquartile range is the best measure of spread to quote. Finally, we will define what is meant by the 5-number summary. It is quite simply a listing of the max, the min, and the 3 quartiles. In a later chapter, we will use the 5-number summary to construct a display called a box plot. You can always check your calculations using StatCrunch. Here I have displayed the output from StatCrunch, and I have highlighted in yellow the 5-number summary. The mechanisms for doing this will be covered in